I'm Van Hauser. You might know my tools, THCScan, AMAP, Hydra, lots of article, and our famous website. And you have the pleasure to be the second group to be presented the IPv6 attack protocol suite. But this will not be the only presentation I'm doing. That's why I removed some slides to get it up to speed, because there will be another presentation directly afterwards, which I hope will fit into the time frame. If not, it will take longer. Which will be about another project we are now starting. This is THCScan Next Generation. So we don't have much time. I'm just jumping in directly. So what I will do first, a very fast, very, very fast, 3 slides, introduction on IP version 6. I tried to get another hour to do an IP version 6 primer, so you understand actually what is IP version 6, how does it work. It looks pretty simple at first, but it's very, very complex. So it will blow your mind just with the 3 slides. So, but CCC said, oh, no time. Our schedule is so full-blown, no chance for that. So, but without, they said, I should assume everybody knows everything about IP version 6 already if they're in that room. Sure, yeah. Then I'll show you a quick introduction on the IP version 6 attack suite, which will then show you how to exploit the security vulnerabilities in IP version 6. There are protocol inherent vulnerabilities, and this is the first toolkit where you can exploit all of them. Well, there is no other tools which exploit them so far, so that's the only one. Yeah, then very shortly, what are the known vulnerabilities, so implementation vulnerabilities so far, but only a very small excerpt, and then what is upcoming research from us, and what will be the future of IP version 6. So, first, why IP version 6? I mean, have you seen IP version 6 somewhere so far? Yes. And if you look on our wire here, yes, you will see it. We have, at every time, we have a minimum between 50 and 150 activated IP version 6 devices on our network here. Every Linux box, most BSD boxes out of the box run IP version 6. We'll come to that later, because this can be interesting. The second thing is, in some companies, it's already deployed. In South Korea and Japan, it's very big. So last month, I did that presentation, a bit longer, in Tokyo on a security conference, because it's really affecting them. They are one of the most numbers of users of IP version 6 in Japan so far. But we will see it in about 2 years in Germany as well. Not necessarily on the internet, or internet too, but in home area. So on your kitchen equipment talking with each other, and we see it on the mobile phones. Because T-Mobile and all the others have very big problems with the IP space. You have lots of subscribers, and with services like always on, push to talk and all that stuff, they need to have an IP address all the time. They're using Class A networks, the 10 Class A network, it doesn't fit cross-country. So they need a solution for that, and they will move to IP version 6 like Asia already does. So, what is the goals of IP version 6? The most impelling one, and everyone will agree, okay, that's why IP version 6 is important, is that there are much more IP addresses. IP version 4 address space is very small. Also, there's much recycling going on now, not to be forced to move to IP version 6. But if you see that, it means that every one of us can have several million IP addresses just for every person on Earth. That's pretty cool. So that's why IP version 6 was, in the first place, was designed. But just doing more larger IP address space, you can do more if you define a new protocol. And now IP version 6 gets very, very cool. You have auto-configuration of IP addresses and networking. You have in the protocol something like DHCP already included. Like router discovery is all in there. You just plug any device there, and it can talk to everyone else and go on the internet and everything. Auto configuration, that's so cool. You just plug in another router. Nothing you have to do for configuration. The device will automatically, oh, there's a new router, cool. To which address does it go to? Oh, great, let's use it. Auto configuration in the protocol, that's very cool. You can do a hierarchical address structure, which makes administrations or network administration much easier. And you have integrated security features, in theory. I'll come back to that later. No, the security features are there. They're very good. They're effective. But, well, we'll come to that later. So this is the IP version 6 header. So if you know how the IP version 4 header looks like, and I had to remove this slide because there's not much time, you'll see that it looks pretty similar, but some headers are not there. We'll come to that later. So there's, for example, no IP ID field anymore. You see there is no option stuff in here. You just see source, destination, payload length, what the next header is, could be TCP, UDP, whatsoever, hop limit, flow label, class, and the version. So like IP version 4, just these fields being larger and some other stuff removed. Why is that? It's a fixed header. And this is what the routing guys always wanted to have, a fixed header. If you have, like in IP version 4, a variable size header, you always have problems with routing packets because you have to know how big is my IP header. And then, oh, it's like this, well, bad. So this is why IP version 6 has a fixed header, and everything are option headers. And this is very nice. So you have extension headers. So you have your IP header. Somewhere later, you might have your TCP, UDP stuff like usual, and everything which is optional, like source routing, you have in IP version 4, you have the same also in IP version 6. These are extension headers, and this is pretty cool. So whatever extension you want to have, you just put in there. So this is pretty easy. And if a system has not implemented that special option or extension, it doesn't matter, it just jumps over it, and everything still works. So this is very neat, very clean design. So this is an example how it could look like. You have the IP header, then the TCP header, and then the application data, or a routing header, then a fragment header and stuff. So that's pretty cool. So that's the basic concept. One more thing about the addressing. Your IP address in IP version 6 is based on your MAC address, the host part of your IP address. This is the calculation on if this is your MAC address, this will be your IP address. Yeah. There's a privacy extension which makes this random and change this every hour, day, whatever you configure it. So you can have a privacy extension, so your IP address is not reflecting your MAC address. But normally, this is what is done. And it's actually pretty clever because a MAC address is usually unique unless you manually reconfigure it. So there will be no collision in IP addresses. This is a basic example. If this is your hardware address, this will be the host part of your IP address. Okay, with this knowledge, we can already start. IP version 6 were first used by hackers and not by network geeks or whatsoever for special reasons. First, mostly it was used for backdoors. And then enabling IP4 to 6, 6 to 4 stuff, because all the analyzing equipment of the white hats were not able to analyze that. So Lance Spitzner was the first to find that on a honeypot, where a hacker hacked his Solaris box, then enabled 6 to 4, 4 to 6, and, well, hey, Etherreal doesn't show me anything. What can I do? Fuck, what is this guy doing? So this was the first usage, so to hide backdoors and to prevent analysis of the traffic. The other thing is where's exchange, REC bouncing, and stuff. The hackers were really the first users of IP version 6. Usually the sex industry is first using something, but here hackers were first. So when we come to hacker tools, what do we have so far? There is not much. And that is what I saw as a problem here. So we have some port scanning tools like Nmap, HalfScan 6. There's a patch for Strobe, but they're not working very well. You can have lots of problems because, why does Nmap doesn't let me scan? Well, there are reasons for that, but that doesn't matter. There are some port bouncers, like we'll say 6-tunnel, NT 6-tunnels, Azibor, Ninalov service tools, which are mostly connection flooding tools, some packet stuff like libnet and i66. And what I did, I tried to implement the hacker tools for IP version 6 to attack the protocol, and I tried to use libnet, it just didn't work. It had I needed important features, which it didn't have, I tried to implement it in libnet, and it was a nightmare. So I wrote my own nightmare. At least I can understand. But all the specific IPv6 stuff, yeah, so attacking the protocol itself, there is nothing. Which got me off because I wanted to play around with that. So I had to code my own. Usually you have to wait until something is widely deployed to have tools available. Well, but I didn't want to wait, and so I'll make this available to you. So it's a very easy to use library. You can do numerous of IPv6 exploits in just 5 to 10 lines of code. All the stuff I will present later, all the tools are already included. There are some caveats in that. First, it's Linux 2.6 only. I started coding it on Linux because that's my favorite operating system. 1 hour later, I thought, let's shoot all the programmers who did that implementation in Linux because it's broken, it's incomplete, and the interface, user space interface, is absolutely fucked up. So it's 2.6 only because I use a proc system, which was the easiest to implement fast. It's little Indian, 32-bit, and Ethernet only. So you can play with wireless, and here with a cable, Ethernet, wireless Ethernet works perfectly, so this will be no problem at all. For most people, yeah. Some like the 2.4 kernel, some like FreeBSD, OpenBSD, Mac, whatever. Well, you're fucked, sorry. So it comes with some tools. This is just I just showed them some of here, but we get into them later anyway. Implementation is very, very simple. These are 3 lines to generate an ICMP echo request. You see lots of options, and you think, can't this be easier? Does it have to be so many options? Reason is I made it like you can change any single byte in that packet like you want to. So this is why it has so many options. But beside that, very few lines of code. Okay, so executive summary, and then you can sleep the next half hour. IP version 4 and IP version 6, the implemented security is very similar. So also vulnerabilities are very similar because the basic mechanisms are all the same. I will tell about the other stuff later. So in the next half hour, I will show you what are the protocol changes, what is reconnaissance, how you do reconnaissance in IP version 4, how this will change in IP version 6. This is very important because there will be large changes for us as hackers. Local attacks are placed DHCP, how this will be done in IP version 6, smurfing, routing and fragmentation attacks, and finally coexistence stuff, like we already have here. So protocol changes. There are 2 things which change, which affects our work as hackers. The first is there is no IP ID field anymore. This was very nice, as in the usual implementations like Linux. You can see when was that machine last booted, because it starts with 0 when you boot the machine, and every second gets incremented by 1. So very easy to see when was that machine last booted. Not highly security critical, okay, but it's interesting. But they removed that, so this is not there anymore. And the other thing is, they removed the IP record route options. Who knows about that option? Yeah, there's not very much. How many people know how traceroute works? Lots more. This is cooler. Because traceroute can easily be filtered. You can configure on a router, hey, I don't want to send any time to live exceeded messages because it just costs me performance. Just throw packet away and be silent about that. Record option is something you can't turn off on the routers. So you'll get them anyway. Drawback is you can only have the next 9 hops. So you must be near the target you want to traceroute to. Ping minus R, that's your traceroute alternative. Very cool. And not many people know about that. So the next change is there are no broadcast addresses. And this is bad. Broadcast makes life for us so easy. There are no broadcasts anymore in IP version 6. What you have instead are the multicast addresses. Multicast means you can say any node, local, or just the local